Hello, this is the last day, and I must say, you can start the tape now. This is the last day, and boy, there's so much I want to tell you, that so little time, and so on. So I'm going to have to probably not say everything else that I've learned about tech in this last day. First of all, to old business. On reflection, the solution to the right justification problem, problem 5 yesterday, that someone suggested in class, of changing carriage return to be a type 13 character instead of type 12, probably is, I shouldn't have silenced it so quickly. It probably is a better solution than the one I had. In fact, it's a nice to redefine the paragraph that way. I don't know why it didn't strike me yesterday as I think it's probably the better solution of the two alternatives. When I finally write Appendix D, I'll check both out very carefully and see if I can think of any bugs in them. The other thing is, can we focus on this? I want to mention this is a certificate presenting to our teaching assistant for his voluntary work for these times, and also this is okay. Now we've got. Now I also have certificates like this for everyone who solves a challenge problem, and in fact, there's one person who has such a brilliant approach to the challenge problem that even if he didn't finish it by noon, I'm going to give him a certificate. And then there were great solutions to the homework problems that were turned in yesterday. I have to show you those because these are not only solutions but beautifully formatted and commented. You see, this is problem number 1, and it puts the solution in, and so on, and then gives the output on the same page. Problem number 2, the same thing. Well, the output had to go on the next page. And problem 3 and problem 4 and so on, with all the things getting solved. So this is a beautifully formatted document, and combines the solutions with the outputs and everything. So that also was very meaningful to me. So I have made up some official licenses also for the perpetrators of that document. And as I said, this is the problem I had with the Dover this morning. When I first tried to print those licenses, it said no output. Page 1 is too complex to print. And I said, oh no. What am I going to have to do? Print it in sections and paste it together? And it turned out it was the Stanford seal that I intended to just include underneath the gold seal that was making it too complex to print. So we just left off the Stanford seal, and it got simpler. Okay. And so there's a couple of other words, but I'm running out of seals, so I hope there weren't too many solutions to the challenge problem. Can you give this to Barbara? Now, the other things that I wanted to mention were questions that people specifically said they would like to see discussed this week. And one of them is about struts. This is such an important topic, I don't know why I didn't bring it up earlier. Because it's really basic to writing lots of macros, that the idea of what's become called a strut. I think Terry Winograd made up the name. Let me give you an example of a definition of a strut, and then you can see what I mean. We have this on the screen. A strut would be, for example, lower the ones that I've used typically with 10-point type on a 12-point base. I would say lower 3.5 points VBox to 12 points of nothing. Now, what does this do? It makes a box that you could insert into a horizontal list that gets lowered 3.5 points, and the VBox was just empty, but it was 12 points high. After it's been lowered, there's 8.5 points above the baseline and 3.5 below the baseline. This is typically the size then of a line of type if you're setting on 12-point lines. So you have 12-point lines, and each one you could consider having 8.5 from the top and 3.5 depth. Now this is useful primarily when you want to put butt boxes together. You have some kind of a macro that builds a V box, and then you want to put another V box next to it. See, according to the rules of V boxes and boxes in general, we have only one reference point for the box, and it's the reference point of the last baseline. So if we built a V box out of a lot of independent H boxes, TeX has forgotten where the baseline was of the top line. And it doesn't have in its data structure any room for more than three things about this box: the height, the depth, and the width. So if I wanted to add another component to it, then that would seriously complicate TeX coding and usage of memory for all the simple cases. But it does only have these three numbers for any box. This is to be considered the baseline of the box, and here's another baseline, and so on. Now, there are different ways to work with this. There's the V top and V center will take a box and center it, or V top actually goes back and runs through and finds the top baseline in the box and changes the baseline of the whole box to be the baseline of the top box. So there is something in TeX that will actually go and find the top baseline of a box. That's only allowed in math mode, but you can always go to math mode if you need it, so that you can, if you want to continue some TeX and then have a box that agrees on the top line, and then has something sticking out underneath it, you can do so with V top. However, there are these other cases where you build a box and you build another box and you want to put them together, and it looks bad if you put both of them together and it's just the height of the top box butting against the depth of the bottom box on the top one, because the baselines aren't exactly the same distance apart. And so fortunately, there's a simple way to get TeX to make nice-looking output even without adding all this complexity to its internal memory usage and data structure, and that's a strut. We assume that that our text is not terribly exceptional. In the exceptional cases, in fact, this will do the right thing also. We put a strut right at the very beginning of this top line here, and a strut right at the end of the paragraph, if this was H box par or something like that, or at the end of the last line on the box. And inside the box, the baselines will be 12 points apart, just as correct. Okay. Now, if you take two of these boxes and put them together with the line skip of 0, then even though the baselines are very far apart, TeX will put the boxes right next to each other. And this is to avoid the problems of two boxes. Usually, the height of this box would only be the height of the tallest letter in that line. Sometimes you just didn't use any letters like B or D, and you had shorter letters in the box, and that would make a difference. Similarly, the depth of depends on if you have any Y's or J's in the last line, so and that would affect the baseline otherwise. So we put the struts at the beginning and end. So typically, if you're defining a macro for a user, that's going to be used to combine boxes, and that these will be tacked into a vertical column or something like that. Insert yourself a strut at the very beginning and first line and the very last line. You can also do it in H-align. You can stick a strut in the preamble to H-align. Like if I'm defining a general macro for math package, and I want to make a matrix, and it turns out that the matrix is done usually with a V center and then an H-align inside the V center. It's good to put a strut in here in each line, just because otherwise you might have a matrix that has A, and another one that has B, and this one would come out a little different from this one, so they'd be centered slightly differently. Parenthesis would be the same if you're lucky, if it doesn't come right at the boundary between one size of parenthesis and the next size. But these boxes would be different sizes if you didn't have those invisible struts in there, because the B is taller than an A. All right, so wise to put the to have invisible struts in general purpose macros. Otherwise, I mean, this is where they appear. The user usually doesn't ever have to worry about them or see them. The question is, what's the most efficient kind of a strut to insert? Well, it isn't a primitive of TeX, it's possible that if these things proliferate, we have room in the data structure to add a strut to the thing. Right now, this creates a box in memory, takes up 5 or 6 words of memory, even though the box is empty, just to record the height, the depth, and the width, and the fact that it's glue set. You know, the setting of the glue is 0, but it's in every box. You'd save 2 words per strut if you made it a rule. For example, if you made it a vertical rule, width 0, and then height 8.5 point, depth 3.5 point, something like that. That would also give the same effect, because a rule of width 0 doesn't print. It takes up 4 words of TeX data structure. It doesn't have the room for the glue set. It's longer. It's a longer piece of text that TeX will have to scan every time it sees the word strut, but it's not that much slower that it would make a big difference. If you really wanted to minimize the amount of text to refer to a strut, then you would probably reserve a box and define box 8. Save 8 or some number to be an H box that has this lowered V box in it, and so on. That actually is taking up more of TeX memory, but then you could say copy 8 instead of strut every time you minimize the length of text that TeX has to read in order to do every step. But that's not really saving you any time, because it has to do the copy operation subroutine. Anyway, that's kind of ridiculous. Okay, there's different ways to get the struts in there. Main idea of a strut is a invisible box that gives you firm knowledge about the height of the top or the bottom of some box. Okay. Another thing about that was my first topic that I wanted to mention here. Another thing is PAR, \PAR. It's possible to match when you're defining a control sequence. This control sequence \PAR will match a blank line. If you're defining something, and then you have number 1 terminated by PAR, this will be terminated by a blank line. Similarly, you can redefine PAR. At one point you couldn't, but now you can. You can redefine PAR to be something else. Probably even with parameters. It would be interesting. And that will occur with whenever a blank line is sensed, then this macro will get called. If you've redefined it. Now, of course, if you want some point to tell TeX to end the paragraph, and so before you've redefined it, you'd better save something TeX paragraph routine equals PAR, or else you're going to never be able to get out of horizontal mode. It's the only way to get out of horizontal mode. You'll be stuck. Inside of braces is another way. Yeah, it goes away at the end of a group. True. Okay. Now, another thing is, someone asked about additional symbol fonts. Well, one thing you can do in the middle of a math formula, you can have a $, then you have an H box in the middle of that formula, and here you can do a math. You can change math x. You can get new variable delimiters if you want. If you have 2 kinds of variable delimiters in the formula, you can use them. You have to set that up. Math x, some other font name for your delimiters. Before you go into math mode, the fonts that you're using are in math fonts are saved away in a stack like the stacks for codes and so on, at the time a $sign occurs, and then in here I could use square root, and I would get a square root from the new extension font. Similarly, the math Roman font could be changed. You can specify the three different sizes of that. You could have XYZ for your math Roman fonts inside of this thing, and then it would use different letters in that font. And this is the way we, for example, we're going to have both old-style numerals and new-style numerals. And if somebody calls for old-style numerals, then then he can just refer to numbers in here, and they'll come out in the old style. If the Roman font has been changed in the middle of a formula, while other numbers, like you might want to put those old-style numerals into a matrix or something like that. So you could also switch to a bold symbols font if you have a whole section of your formula you want it to be bold. Computer Modern has these bold symbols fonts, but nobody has ever generated them for their font libraries yet. But they're there, and I tested them when I designed them. I think they'll come out okay. You could even have a bold math extension font. Now, the other thing is there was a little thing about H fill versus 1L fill versus 2L fills. This one is an abbreviation for a stretch of plus 10 to the 5th points, and this one is plus 10 to the 10th points. So this is a strong amount of stretch, and this is a very large amount of stretch, but this is much larger. The effect of this is that this one is like infinity squared, and this is like infinity, or if you prefer, this is infinity, this is square root of infinity. But it depends now. If you have only H fills with 1L in a formula, then they will act like fillers. But if any H fills with 2Ls are in there, then all the H fills disappears and sort of are wiped out to nothing. And this has been used, for example, to design macros where where you want to center something. You can put H fill around both sides of it, or HSS also is of this order of magnitude. Then somebody puts an H fill in there. That's enough to override the thing for stretching. For shrinking, it wouldn't on the HSS one. So then that would allow somebody to left justify something or right justify something inside of a macro that's normally centered. Question on that?
Yeah, could not one have simply specified a glue of plus minus 10 to the 5th points on the opposite side that you didn't want?
Yeah. If somebody has put H fill on each side, you can also put a H fill neg, which cancel. We don't have the negative of that one as a primitive, but you could also write it in specifically 10 to the 10. Well, H fill neg will cancel H fill, and that will and that's another thing. That's another way to do it. Yeah.
The reason I'm asking the question is because, person X defines macros with H fill, and person Y calls them and wants to cream them, so uses H fill with 2 L's. Then person Z calls them and wants to cream them and has to define an H fill with 3 L's. Pretty soon your numbers are getting pretty big. But if you minus them out, you could go indefinitely, pretty much.
That's right. In fact, 3 L's would exceed the floating point capacity. Probably has somewhat. We're going to start doing fixed point arithmetic later. Yeah. The negative cancellation also works in that way, but this H fill is somehow more mnemonic if you're going to have 2 levels, and that's why, for example, when you write in a fraction, if you write A H fill over B plus C, internally TeX uses this kind of glue, and so that's going to come out A over B plus C like that. So you can use it in a math formula, and the naive user would just like to probably put an H fill there, and inside it has 1L. But that's right. If we're going to have to get in a hierarchy where everybody's fooling everybody else, then they have to cooperate a little more and decide on something, either to use 10 to the 3rd or something else with negative cancellation. I'm with you. I think negative things aren't that complex, but a lot of other people are afraid of negative numbers, and I think most of the like my daughter's teacher, for example, or my daughter's math teacher. Right? Now let's see. The challenge problem, I have I received one solution here. I haven't seen how he did it. Let me see. He did it with bot insert, apparently. Okay. Well, anyway, now I know of 3 solutions to this challenge problem. 3 different approaches, and the main idea in all of these 3 solutions is given by the first line of the challenge solution. Can we pass that out, please? The first line of the challenge solution, which says, this is just a solution that I had when I made up the handout. Can we have it on the screen, please? The V size 8.5 point. That was the key to all of these methods, saying that that every time a line comes out, it's going to go to the output routine, and then the output routine is going to save it away and make the real pages somehow some other way. Okay, so that's the first step in the solution. But that's not all. You also have to figure out how to get the information to the page routine about what it's supposed to stick in the margin. And so there were 3 solutions. Well, by the way, the top baseline and max depth, I go with that, essentially saying that one line at a time, we'd like the top baseline to be positioned so that each time I put out a page, it's going to be the first line on that page will be 8.5 points from the top. Now the 3 solutions, one of them was to use marks and to put out a mark every time you got to a new verse, because that mark is something that stays with the that can go to the output routine. The output routine can read marks. One little problem with that solution is that if you try to use marks, you get an error message saying you can't do that in horizontal mode. All right. However, next week you will be able to do that in horizontal mode. I found out that with only 3 lines, changing 3 lines of the TeX program, it'll work beautifully. And all the instructions were there, and I know it's not going to mess up anybody's existing program because they would have gotten an error if they tried it now. So TeX will allow marks in horizontal mode from now on, and these marks will just stick there inside the paragraph, and whatever line they happen to appear on, the mark will appear right following that line, immediately following that line, just as the way inserts do, and sends don't get put out. Oh, ejects also. The page break and eject disappear out of the H box of the line and go back into the following into the vertical list right after that H box. So marks will work next week, and that's very nice because mark is a way to communicate lots of things to the output routine. Now, that's something I should mention also. When you say mark in the ordinary sense to the output routine and you give some text here, the original intention of that was that this would convey one piece of information to the output routine. The output routine could have top marks and bottom marks and so on. Now the question is, what if you have 2 things you wanted to tell the output routine and it wants to use one of them in one place and one of them in another place? Well, my first solution to that problem was very hairy, but I didn't know how to generalize it very well to 3. But I used to send a mark which would be either T followed by something or F followed by something, and then I would call the mark with an if test in front of it, and it would select. I guess it also had the else in there, and the mark would come in this kind of fashion, and then it would have 2 pieces of information, and then I could call it getting one or the other. But that was very kludgy. But there's such a simple way to give as much information as you want in these marks just by saying like gdef MA to be the first kind of thing, and then gdef MB to be the next, and gdef MC to be the next. And then in the output routine, you simply execute your top mark, bot mark, or first mark, whichever, or all 3 of them. And at first you'd execute maybe top mark, and then you'd save away MA and MB and MC in some other control sequences. Then you'd execute first mark, and then you could have all the 9 pieces of information. Say if there were MC and MA and MB in every mark. and then the output routine would be able to use all 9 pieces of information and make decisions based on that and so on. So that's a way to convey information to the output routine via marks. Quite powerful. So, oh yes, somebody asked me, oh Barbara, I forgot to bring your example. Somebody said, okay, Barbara Beaton is here from AMS and she's trying to put out the catalog of publications. And this is one of those catalogs that's grown over the years and has all kinds of different printing formats in it. It's been quite a challenge to design the macros for it. And one of the things that there's a big index to it, and there's over 1,000 publications, and they all want to, each one wants to be in the index under a code name rather than change a lot of existing files. It's turned out that she wants to define 1,000 different control sequences to read in. On Ascend, she's going to define 1,000 different control sequences and then read those all in when making the index. Those will tell you what page number the particular publication was on. But the problem that she wrote to me about, she said, what about on every page she'd like to put a $ in front of the prices on the first thing on the page, but not on any other publication. So wherever the page breaks happen to occur, the first one on the page is supposed to have $ in those. Do you have it there, Barbara? Oh, good. Let me show you the problem. Oh, this is okay. So there's the $, you see, and then you don't have $ afterwards. The next page doesn't have any $ at all. Here's one. This is the problem. How to make that work? Okay, and the answer, I'm afraid, is to do it in 2 passes. I don't know of any way to do that kind of a conditional thing in 1 pass, but I think it's legitimate to do some things in 2 passes. The first pass to figure out where the breaks are going to occur, then a person can just insert a few ejects into the file, knowing that the page breaks are going to occur in that place. Because this is where we're combining all kinds of optimization at once, and we can't the change in the text might very well affect the place of the page break, so we'd be in a vicious circle in many cases. Do you have an idea how to solve that?
Yeah. Is the $ supposed to appear at the top on each page?
No, it's in different places.
Oh, okay.
Can we take a look at this one again? You see where? I mean, it should be up there, but it might be on the 3rd line down. Is that what you mean?
Yeah, because if it's predictable, you know where the column is going to be.
But here I want it on the 2nd line down.
I see.
Here I wanted it after this, after this little preamble. So yeah, it's.
So you could still get away with that.
I'm saying that there are probably going to be problems. Maybe that you might even think of a way to do it, and you can work it out after class. But there are going to be problems which 2 passes will be accepted. Now, another thing could be done, in fact, is when she sends to a file, she could send not only the page number where these are, but whether it was first on the page or not. It would be possible to determine that, I believe, by reading that file and figuring out which things are first on the page, and then nothing would have to be changed in the input file. It could all be done automatically. Do you have a
Yeah. This may be kind of naive because I haven't worked in tech for a while, but what happens in front of every single price? You put a macro name there, and the output routine defines the macro name to be a $, followed by the macro redefines itself to be nothing.
Right. The solution. That's what happens when you get this, and that's what she's done now. And the reason is that TeX will read ahead and in its vertical list until it finds the best possible place to break a page. So it might be halfway into the next page before it called the output routine. By that time, these other things have already been boxed and put away. Jim?
I'd worry about mem size if I were trying something like this, but you might be able to use a relative of the point macro from yesterday's class and have the mark tell what the coordinates are.
I don't know how to get that information in TeXsource. Okay, well, you can think about this one and see if you can. If you solve it, you might get an acknowledgement in the presence of the next catalog publication. But I have a lot more to cover today. There will be there will be cases then, I think, where it's meaningful to assume that that a person will do trial setting, and this is for some complex jobs. I would say this is since it doesn't cost that much computer time actually to get these trial settings and get the proof copies, then we're actually ahead by doing it that way than by doing something that's going to be flaky and cause some other crashes someday. Well, anyway, that's the one problem that people were saying, what can't tech do, and that's one that might not be able to do. But maybe we'll think of another one. Now I got to tell you, the first solution then to this challenge problem was to use marks. The second solution was my solution, which used inserts, top inserts. And so what I did was after getting a line on a page, if there was a new verse starting on that line, then a top insert would go in. The top insert would be of some box that would set the number in the margin. Okay, and the top insert would also have glue forward and aft, and there would be a top sep also which would separate the top insert from the text itself. And so I'm sitting there with essentially a V-skip and then a box, an H box, and then another V-skip. That's my top insert. And then I have the top sep, which is another V-skip. And I was allowed to fiddle with the parameters so that if you plugged in what happens when there was no top insert, when there was a top insert, or when there were two top inserts, everything would get positioned in the right way. And you can check it out on the solution sheet that it works. It turns out that the way things come out, every time you do the calculation to send something to the output routine and to V-box it to 8.5 points, it turns out that the glue is either 0 when there were no top inserts, or -1/5 when there was one top insert, or -1 when there were two. But always negative, and so it'll always do that right thing. So that was a way to convey these three things and get them to line up right, just by computing the glue properly. And it was a little interesting exercise in mathematics to figure out how to make that all check out. The people at BNR will have to use a new version of TeX though before they try this, because last Saturday when I was preparing my handout for Monday, I found out that the calculation of depth of a page was incorrect in the old version of TeX. Had been incorrect for 3 years. Nobody ever noticed in the presence of inserts. And it was very complicated where the text came and then the insert came, but what was the actual depth of that page? And that algorithm was fixed, Pat.
We actually tried to use inserts. Unfortunately, our version of TeX doesn't have top sep and bot sep yet.
Oh, is it?
It produces the new DVI, which we have nothing that can read the new DVI.
Yeah, so there's this problem with when we're talking about these things on the cutting edge that they are things that were not as well understood a year ago. So although TeX has been remarkably stable, that was up until last Saturday. This week I put in 7 different things because of just preparing this class and rethinking things over in much more deeper form than I'd ever been forced to do before. So so that's another reason why it might not have been so easy to solve the challenge problem. Okay, now the third solution to the challenge problem is really fantastic, and this is to convey information to the output routine by using the depth of the box that gets set to the. Okay, so this person recomputed every time a new verse would come in. He recomputed a longer strut with more depth. Okay, and so then the length of the depth of the V box that goes to the output routine can now be can now be read essentially, and then you can check it out and find out what it is, and then branch to whatever routine you want. And gosh, that deserves a gold star. I'm sorry to say, it's too it's really weird, but works. So that was the other solution to it. Now that's. Who knows what people will think of next week? Yes, Pat?
Sends could be used instead of marks if sends could be controllably sent to the output file and read back in. Why is it that sends only happen when you actually cause output to go to the DVI file or whatever output file?
Okay, sends only come at output time, because this was important, that we wanted the information that's sent out to depend on the page where something appears, rather than to depend on the place where it is in the file. Since TeX is way ahead of itself on building pages before it decides to send something to the output routine, we need some way to have things that would be independent of this asynchronous process. So the idea of marks was intended to, the first thing, to counteract that. The second thing is send also evaluates counts at that time. So you want to know exactly what page something appears on. Therefore, send is not going to appear at the very moment of sending. Now, if someone wanted to send something instantaneously, that would be another thing that could be added to TeX by just looking at the way the send works now and probably building it in. There's a provision in TeX for extensions. These extensions, I hate to have anyone write. Anyone expect to use one of these extensions and then run his program at another place. But there's a separate module that makes it very easy to link in your own extensions into TeX. And some of the extensions that people will think of, then maybe in 10 years we come by with another version where some of these extensions become frozen into a real one. But meanwhile, I'd like to, and we soon will, have all versions of TeX again in sync with each other. And I've tried not to put in every possible extension, because there's no way to do that. I could easily spend my life putting in another extension every month, because someone will keep thinking of more things to do. The first thing you learn when you start working on software is that every user has his own pet new thing to add to the language. So I tried to hold the line. And when something takes only 3 lines to, like this mark in horizontal mode or something like that, then I don't, then I'm in a weak moment, and a day later I stick it in. But sometime soon I won't even do that, because stability will be more important than yet another new feature, another page in the manual. Somehow the size of the program in TeX tends to be 1/3 to 1/5 the size of other typesetting programs that don't do as much, and it's because of this paring things down, but still being able to program the things that we want. Now, this idea of outputting one line at a time indicate one of the main reasons I wanted to show it to you just now is partly to open your eyes that output routines need not only have multiple columns, but they might have multiple lines, but also to indicate that if you had to write a simulator of somebody else's paging mechanism that didn't include the optimization of breaks over V-fills, you could do it. You can slow TeX down to the level of other typesetting programs by programming your output routines in this way. Now, originally I didn't know that would be true. Originally I had an output routine that was good enough to do the pages of the Art of Computer Programming. And after about 2 months, it occurred to me that maybe I'd be able to write one for the index also, which was double column format. and it took me all afternoon. And at the end of the day, I was really delighted to find out that without changing text, I was able to actually produce double column format in the index routine. I had no idea originally that it would be even that general. And then, as time has gone on, we've learned how to do almost incredible things in output routines. Now, I wanted to show you this, and there's a handout. Have you got the 2-page handout? That 2-page handout is about balancing. And it shows a possible solution to problem of balancing copy. Here was the output of the copy. These are, let's see, we don't have to focus up to see the letters. Just go zoom back so that we can see just the pages as they are. Okay, now there's the Grimm's fairy tale that we used in another example is illustrated here in a 2-column format printed by this thing that was done in your handout. And this is a nice little, this was the very first in Grimm's Tales. And if you want to read the story, go to the library and so on. Then I did it again. And you see what the problem was to get the columns balanced and then have a new title and then start over appropriately there. Okay. Now the second setting of this is exactly the same, only the title has been restored to its original. And every paragraph is set 1 line loose. So each paragraph in this is actually 1 line longer than it was previously. And so you'll see the way the end of the paragraph tends to be short. But I didn't. I think I stretched. Well, anyway. Now widow line, couldn't help it. Fixed. No, there was no baseline skip in this particular example. Okay, so then the third one, this is 2 lines loose, but you see again, these macros are supposed to handle this balancing and restarting and getting going again in the proper way. This is 2 lines loose, you get a few rivers in a short paragraph. And here on the last line, I made one of the lines so that it was only 1 line loose, I believe, because there were an even number of paragraphs or something. Or maybe there was one paragraph that couldn't be made 2 lines loose without exceeding tolerance. Anyway, you see, you also have the problem that there's an odd number of lines, and so you have to balance it, and you have to make sure that you get the extra line there. Okay. So that was the problem that this macro attempts to solve. And I didn't give you the output, but I gave you the input. And the input in the source file had I had a clear above title, means I guess starting a page at a title. And then I gave the Frog King, and I gave JPAR 27. That means I'm allowing certain width of spaces. At most 3 cubed, most 3 times the stretchability. So that means you go up to, I think, 1M space at the worst. Then there was the beginning of the thing where I did poor man's small caps. I did this caps and small caps in a hard way then, but I did put the I to stick up a little higher. That's, a little bit of, that just came out like that. So then I said, in this case, I had to say prepare. Somewhere near the end of the story, I had to say get ready. Now there's a way around that, but first of all, we have all the hyphens in this file. It turned out because I had already built this file for lots of different tests on my paragraphing routine, so I put in all the hyphens to make sure that my hyphenation algorithm wouldn't interfere with my other experiments. And then at the end of the story, it says balance. Okay. Then we do the same thing. This time setting JPAR way up and loose 1, and then do the same story again and balance. And similarly, loose 3. Oh wow, that was for the very end of the story. I did loose 3. That was how I was able to get an odd number of lines. And finally, balance and then flush at the end. So that's the source. The solution is on the previous page of the handout and how it actually works. Well, the basic idea is that when you say prepare, from that point on, the V size is changed, and TeX will just gather along the text from that point on into one long list. And then at the end you say balance, and at that point it changes the V size back to it figures out how long this list is, this page is that it has built, and then it takes half of that and sets the V size to half. Then unboxes the text. It puts out the balance routine. The output routine just saves this away, and enough information for the routine outside the output routine to start to unbox this saved away box and get more information out into the output routine. The output routine itself can't include the unbox. The unbox instruction has to be done outside the output routine. So the problem is to communicate from the output routine to the non-output routine, saying now it's time to run the box through. That's why I had this preparation step essentially, and the balancing routine is done at a quiet time at the end of the story, when we know that there's nothing else coming into the output routine. Okay, so that's now the unboxing sends everything back through into the page again. The baseline calculations between the calculations of glue between lines is not redone, but the calculation at the very top of a page is done. The calculation to get the top baseline on a page correct is carried out. And the stretch and shrink doesn't change in the glue. It's the amount of space though between lines has already been determined when the thing was set first, and it's unboxed. The vertical list is just sent right back to the page builder again. After it gets to the V size, then it hits another output routine. The output routine saves away the left column, and the next one saves away the right column. After which the V size is adjusted again, so that we're ready to so that the part of the page that's been done at the top has been stashed away. This part, for example, has been stashed away in some box, and a number saying how big the current page is has been reset so that it's the size of the remaining page. Then the same program works again, and this box is normally empty, the box of things that have been saved from other time. So to put the title on it just makes the V size a little bit smaller. The basic idea then was to use unbox to feed the text through twice. Now we've had even wilder ideas where we can feed the text through 3 and 4 times. It turns out that when you're in restricted vertical mode, the eject does nothing. Like you could do a top insert containing an eject, and it'll get inserted into the top and nothing happens because it was done in restricted vertical mode, and eject is ignored. It goes into the list though. So when you unbox it and put the unbox thing in vertical mode, the eject is now going to force a call on the output routine and get back control into the output routine. And so by sprinkling ejects around in things, you can like after every footnote you could include an eject, and that would trigger a call on output routine, and that's another way to get control back and forth. And these routines essentially communicate with each other by saving away in control variables any state information that's necessary. And it's not like algo, but it's not much different from a lot of hardware routines, and it's humanly understandable with even possible to document the programs and write them in a way that looks almost structured. I didn't do that in this particular handout. The balance routine has a feature that one of the things that, it fits on this one page, but actually a lot of the code is just to divide by 2. I believe I did I programmed the division by 2 in here, or recursive division by 2. Where bisect routine. Oh, okay. Yeah. No, that's not really taking up. Yeah, I see that. Yeah, it doesn't really take up much space, but this is a division by 2 routine. increasing count 7 by the number of lines that are actually to be used on each case. Because there was no glue, it was going to be difficult to decide that the V size should be exactly half of the proper amount. If that wouldn't work because it would come out to be a line and a half, and then there would be a problem. Just feeding the thing back with unboxed. So now if you're dealing with another kind of text, then where you expect there would be glue there, for example, you can put glue in your baseline skip, you can put glue in your par skip. A little bit of glue there doesn't hurt. Although a baseline skip, if it goes up by about 2/10 of a point or 3/10 of a point, it becomes noticeable. But 1/10 of a point, it's not that easy to it doesn't make quite so much visual pollution. It's called carding, because they used to stick in cardboard between the lines in order to make the pages come that size. So you could put some glue in the baseline skip. You could put it in the par skip, space between paragraphs. Has turned out to be a fairly good way to hide widow lines and things like that. Then this kind of balancing work. Now, this isn't the definitive solution to balancing. It's just one approach to balancing to show you how a basis for other solutions. And friends from BNR have indicated a nice way to get around the problem of what about glue that that disappeared. Okay, so let me see. They were solving the balancing problem in this way. At the time a balance instruction comes along, there's been no preparation, and so the output routine is faced with two boxes, maybe one from the left column and one from a partially complete right column, and the output routine wants to take that and put the boxes back together again, unbox that, and send it to the page builder with the proper V size for the balancing. However, what if a break occurred just before a new subheading, and so there was say a skip of 12 points that got deleted at the break between the end of the first column and the beginning of the second column, so that the subheading would appear right at the top of the second column where it should. And so the question is, how could the output routine know when it puts these two boxes together again to get them to work correctly? Well, you can't do that just with struts, because actually we wanted that glue to disappear if the two columns were not going to be balanced. And so they have a nice solution to this. They did it with marks. One of the things that the mark will put out on a line that will go out would be saying that the thing that's coming next is a subheading, an indication of what is coming next, and the output routine knows what format is being used, and it can restore the glue that was there for a subheading. Unfortunately, this didn't work last week again, because there was a rule in TeX that when you destroy glue at the end of a page, you just continue reading through glues and penalties until you get to something else, and the glues and penalties disappear. But when you got to a mark node, it stopped. And then a glue after the mark node would still appear on the top of the next line. So that rule has now been changed, so that when you at the top of a page you can have marks and sends and inserts, and it does not affect the calculation of the top baseline. So the first real box or rule that gets on the page is going to now get the proper top baseline calculated, and before it was almost that way. Unless there had been a send or a mark or an insert beforehand, then the top baseline would get applied. Wouldn't be applied. The top baseline was only applied when it was the very first thing going on the page, and glues and penalties were ignored. So this will now be a nice solution to that problem. To use a mark to help the output routine know if it wants to do this kind of complicated balancing. So the state of the output routine world then is that that this will always be I believe, an area where the most difficult to fathom routines are possible to write, and the alternative would be to write them in some algo-like language that would be embedded within the typesetting system or something like that. It looks like it would be more difficult to make that kind of thing portable. So, I guess I'm resigned to the fact that output routines will be arcane. After all, we can get some fun by. I mean, one of the problems about microcomputers has been that we hate to admit how much fun it is to code in octal again, or I mean hex. But at least it's not stylish to do things like that. Still, we can, so people also enjoy playing duplicate bridge and things, and that's not that structured. It's a lot of different rules, and so I think there's something in human minds that enjoys a bit of arcanity, whatever the word is. Okay, I've run out of time almost, but I can answer your last question if anyone has a last question. Richard. Try again.
I was just wondering again when exactly a send is sent.
Okay. What happens is a send sits in whatever list it was inserted: math mode, horizontal mode, vertical mode, and it just sits there, even is as invisible as a strut. It doesn't have any size. Then all the boxes will contain it. Finally, something is sent to the output routine, and it's actually, for example, somebody's going through all these lists and saying, now let's make the Dover print the right thing. At that point, the send is interpreted. Now, this is after the output routine has finished its work. The output routine has gone on and completed its job, and when the output routine is done, TeX gives an error message if page hasn't been looked at all. So if output routine didn't look at page at all, TeX says that's a little strange, and it gives you a warning about it. It assumes that page has at least been gobbled up by the output routine, but then it looks and sees if this vertical list that the output routine has constructed is empty or not. If it's empty, then TeX assumes that the output routine was just saving for a later day. Incidentally, there's no way to go the other way and have two pages of output come on one eject. But anyway, if it's not empty, then out goes to the DVI file. Afterwards, during which time the sends are taking place.
The idea was that if I'm going along and I have a send on a page which is sending count 0 or count 1 or something.
That's right.
And then it goes on to the next page because it hasn't decided where to break the page, and I've advanced count. And then after that it decides to break the page. What is going to be sent by send?
That's right. So that's why we wanted the send to do it that way. And because the most important use was for table of contents and indexes. Now the other thing I wanted to mention is that notice your output routine will advance the page count, and so that the actual value of count 1 at the time at the time the send occurs is not the page number that it was on, but the page number of the following page. And the typical way to do that is not to output count 0, but to output count 1 and say set count. Can we have this on the screen? Set count 1 to count 0, for example, and then advance count 0 at the end of your output routine. And then the index macro will use count 1. And so then that will be the page that it actually appeared on.
Tom?
Yeah,
Do marks work the same way that if you mark?
Mark will expand counts at the time that the upper routine is looking at them. One more question. This has to be the last one, though, I'm afraid.
Couldn't you use also XDEF?
Could XDEF be used in Ascend?
Get that count fixed at that time to a global name or something?
If I would use an XDEF when I was sending to expand the count at the time of sending, then that would give me the count the value of count that might not correspond to the actual page on which the thing appears. If I expanded it out before I send it. Yeah. Okay. Well, you've all been quite an inspiration to me this week, and I hope also I've been able to convey one or two things that you like. Happy.